Section 5.8, polynomial models in the real world. And what we're doing is fitting data to either a linear, a quadratic, a cubic, or a quartic model. Okay, and this is all done with our calculator, so it's very nice. So basically, what we're going to be doing is we're going to be giving some data, and we need to figure out which type of model is going to fit it best. May not be a perfect fit for any of them, but you want to pick the one that fits it the best. So, the different regressions we can do are linear. You're figuring out if a line fits the data best. Or we could do a quadratic to see if a parabola fits it best. Or we can do a cubic regression to see if a cubic polynomial would fit it best. And we can go one step further and we could do a quartic regression. They're all in the exact same place that we do stat calc linear regression or stat calc quadratic regression. So they're all in the same thing, we're just picking different ones. Now I had you turn your diagnostic on, and you want to make sure that is on when we're doing these types of problems, because that gives you what's called an R factor, a correlation coefficient. So make sure your diagnostic is on to get your correlation coefficient when we do our regression. And that correlation coefficient is given as the letter R. And basically what you want to look at is R squared. And if R squared is close to 1, if R squared equals 1, it is a perfect fit. It fits all the points and it models the data perfectly. Okay? Most often it's not a perfect fit. Sometimes it is, but most often you have a whole, maybe 25 data points, and you're just trying to find the best fit. So, if it's not a perfect fit, you want to pick the regression that gets your R squared closest to 1. Okay? So, we want R squared to be closest to 1. Alright, so what I want you to do now is I want you to enter this data into your calculator to do our regression. So if you recall, take a look up at the screen. To enter data, we want to go to Stat and then Edit. That's where you should have cleared your list earlier. And I want you to put this data in. I've already entered it from earlier today. So we've got 0, 5, 10, 15, and 20 on your calculator, please. And L2, the data that's in the Y's here. So your X is going L1. And your Y is going L2. Again, to get there, it's Stat and then Edit. Stat button and then Edit. Can you guys see the data in the back?
My lists aren't clearing.
To clear the list, better? So, here they are, L1 and L2. To clear the list, you have to put your cursor on the title up here, Paul.
Yeah.
And then hit Clear, Enter.
Oh, clear. Enter.
Yes, then it'll go away. Alright, so we should have all this data in. So when we have these types of problems on tests, it should be easy. You're not doing any crazy calculations, you just need to know how to use your calculator. Okay? Okay. Okay. Alright, so we have all the data in. Not quite. Once the data is in, I won't leave yet, but once the data is in, and we're asked to find the best regression, and when your calculator does a regression, it's just finding an equation for the data. Okay? So, to find the best regression, we're going to look at a linear regression, and we're going to write down the R squared value. And we're going to write down the equation. And then we're going to look at a quadratic regression. We're going to write down the equation, we're going to write down the R squared value. We'll go through cubic, and we'll go through quartic, and the one that has the best R squared value, that's the one we'll use. Okay? Alright, everybody good? Data's in. So now, to do the regression, we go back to Stat and over to Calc. And we're going to start with number 4. We're going to do linear regression. Hit Enter on linear regression. As long as you use L1 and L2, you generally don't have to change these. Okay? frequency list doesn't matter. It might be helpful to have it store the equation so you don't have to write it down immediately. So I tell it we're going to put our linear equation in y1. To get to y1, we do bars over to y bars, function, y1. Now, if you leave that blank, it's fine, but your calculator then doesn't store the equation.
When I press line reg, it doesn't come up with that.
Yes, so the older version, if you do limreg with the older version, it just does this, right?
Yeah.
And so you need to put a parenthesis, you need to tell it L1, comma L2, comma Y1. That says we're using L1 and L2 as our list, and we're storing it in Y1. And then hit enter. Yeah, after you hit enter, that's it. I just haven't hit enter yet. Hold on, it's still clear. Do not clear. Leave it there. Don't get button crazy. So if you have an older version of the calculator, you want to do it this way. Okay? And then hit enter. When you hit enter, so when I come down here and hit calculate, I get that. Yes? Put a comma after your L2. It's above the W. Okay? To get Y1 is bars over by the arrow. Y bar. Function. Y. Okay? Then hit enter. All right. So what I need you to do right now is I need you to write down the equation. And the equation is y equals 0.572x plus 5.24. And your r squared is 0.554. We'll go out to 3 decimals. So y equals, what did I say, 0.572x plus 5.24. And my r squared was 0.554. So how am I fit for a line? Not great. Not great. We're not that close to 1. So let's go try quadratic. You stay right on that home screen. We can go to Stat, over to Calc, and this time we're not doing a linear regression. We're doing a, number 5, quadratic regression. Hit enter there. Same thing, I'm going to tell it to store my equation in y2 this time. This way I get all my equations stored in different y equals, and I can just go look at them.
So should I just do the same thing with parentheses, but y2 instead of y1?
Yep, yep. All right, 0.059x squared. Minus 0.617x and plus 8.211. My r squared was what? 0.763. Better. Okay, but we'll continue on. So now I want you to do a cubic. Write that down and make quarters. Okay, so do that at your desk. I'll keep doing it up here. If you're stuck at any time, just glance up here. I'm going to do the cubic regression. I'm going to throw that in y2. Please write down your cubic equation and your r squared. Oh, maybe it's 0.8. minus 2.297. Yeah.
For the, you do y equals 3.
Yeah, for the cubic one, yep, and then y4 for the quartic one. And my r squared for the cubic is 0.999.
So we've done once again.
I'm going to have you go one more just to show something, okay? But once you got here, you could, yes, say cubic regression is pretty darn good. So that's perfect. But go ahead and do the quartic regression as well. Which is number 7. Yeah. None of them all. Let us get through those. Oh. All right. So what do we notice with the quartic? R squared is what? 1 is perfect. All right. So what this highlights is that how many points did they give us? Total? 5. So given 5 points, this will happen all the time. If we're given 5 points and we know the answer is a function, we will be able to get a perfect match for a 4th degree. If they gave us 4 points, we'd be able to get a perfect match for what? 1 degree less, 3rd degree. So given 4 points, we can get a perfect 3rd degree. We're going to be using that in our homework. They call it the n+1 theory. So if they give you something like 5 points, then you can get a perfect quartic regression. And we can carry this all the way down. If they give us 2 points, we can get a perfect what? Careful. Perfect
Right.
first degree. Okay? All right, so let's see how we're going to use this. So we would choose the quartic. The quartic is the best model, but sometimes they say they only want a cubic or something else. But given this, we would choose the quartic because it fits perfectly, has an r squared of 1. All right, so let's look at some examples from the homework you're going to be doing tonight. So find a polynomial function whose graph passes through each set of points. So if we look at number 9, they're giving me 2 points, I can get a perfect what? First degree, which is a line, correct? So 9, you're going to do a linear regression. 11, How many did they give us?
3.
3, so we should do what kind? Second degree, which is quadratic. There it is. 13, quadratic again. And 15,
Cubic.
cubic. So do a cubic regression. You should take notes on this. This is what you're doing in your homework. So I'm kind of guiding you to the type of regression you need to do for each of these. And it just says find a polynomial function whose graph passes through each of the set of points. So take a few minutes and let's get 9 through 15 done. Yeah, I think it's up. Let me double check. Here we go. Yes, so homework is here. Page 335, 9 through 29 odd, and 35. So right now you're doing 9 through 13 odd. We're getting that done now. All right. So someone help me, what was my equation in 9? Raise your hand, please. I can't do that. Y equals?
Y equals 25
Minus 3, do we agree? Quadratic, CJ, in 11?
I got -0.928 x squared plus 7.785x plus 4.
Yep, do we agree? Okay. Dylan, how about 13?
X squared minus 6x plus 1.
Oh, how pretty. Plus 1? Okay, and the cubic, and number 15, Jesse?
Y equals 2x.
2?
Yeah.
2x cubed?
Yeah.
Okay.
Plus 1.
Plus 1x squared,
Minus 4x.
and then
Plus 6.
plus 6. Do we all agree? Okay. All right, let's move on. That's 4 of your problems done. All right. Now, for each set of data, compare 2 models and determine which one best fits the data. Which model seems more likely to represent each data over time? Quiet, please. So on these, and you can think about what is happening, what you are modeling. So we're going to look at number 17. We're modeling world population. Is it going to get smaller or is it going to get bigger? It's going to get bigger. So this is going to grow big. So they want you to choose 2 models to try out. So what grows faster, a linear equation or a cubic? Yeah, because you raise something to the third, that's bigger than raising it to the first, right? So if world population is growing pretty quickly, maybe we try a cubic and a quartic on this one. So enter the data, and I want you to do a cubic regression. I want the equation in the R squared, and I want a quartic. Do this now, please. And I want the equation and the R squared. Oh, yeah, I can't do that? I can't do that.
No.
Can't do mine at the same time. All right, you go do it.